Investigation 10, page 625, is over probability, chance, and odds. All right, we've talked about probability before. We haven't talked about chance and we haven't talked about odds yet. If you look at the top of the page, 625, it says probability, chance, and odds are different ways of expressing the likelihood that an event will occur. Recall that probability is the ratio of the number of ways a particular event can happen to the total number of equally likely possible outcomes. Okay, we've talked about this. Probability is the number of favorable outcomes to the number of possible outcomes. All right, so if I asked you what's the probability that you're going to spin an A with one spin, you would give me the fraction 1/4. You can also state probability as a decimal, right? 1/4, that's equal to 25 hundredths. So probability is stated as a fraction or a decimal, and we're saying what we want to happen compared to all the things that could happen. Okay, so let's look at example 1. Which is more likely? Rolling a 7 with one roll of a pair of dice, or drawing a face card with one draw from a normal deck of cards? All right, well, if you remember from our chart, the probability of your rolling a 7 with a roll of a pair of dice is 6 out of 36, and that'll reduce to 1/6. Drawing a face card with one draw from a normal deck of cards, all right? If you remember, there are 3 face cards for each suit. You've got 3 hearts, 3 spades, 3 diamonds, and 3 clubs. Okay, 3 clubs. So then that would be 12 out of 52. All right, and we could reduce that to 3/13. All right, so which is more likely? You're drawing a 7 or rolling a 7, or you're drawing a face card? Okay, well, it's kind of hard to compare these because they have different denominators. But you can also state probability as a fraction, as a decimal. So we can just convert these, okay? So let's do 1 divided by 6. 6 will go into 10 once. Okay. 6 will go in there 6 times, 36. Okay. So we're going to keep getting a 4. All right, so we could just round this to 0.17. What about this one here? 3 divided by 13. Okay, well, 13 will go into 30 twice. 26. Okay, and we can already see right here we only have 17 hundredths, and over here we're already going to have at least 20 hundredths. So we can already tell that we are more likely to draw the face card. Okay, so that would be your answer. Drawing a face card would be more likely than rolling a 7 with a pair of dice. Okay, look at the next question. Express the probability that a flipped coin will land heads up as a decimal. Well, we know it's 1/2 as a fraction. What would that be as a decimal? I'm sure you know this. It would be 0.5. 5/10. All right, pretty easy. Number 2, the probability of rolling a 12 with one roll of a pair of dice is 1/36. Express this probability as a decimal rounded to 2 decimal places. Okay, so hopefully you remember how to make a fraction a decimal. You divide the numerator by the denominator. So we're going to do 1 divided by 36. All right, so obviously 36 won't go into 10. Now 36 will go into 100, but how many times? Think it'll go in there 3 times? I don't think so. 3 times 6 is 18. 3 times 3 is 9 plus 1 is 10. Too much. Okay, so twice. So 36 plus 36. Okay, that's going to be 72. All right, so how many times will 36 go into 280? Let's try 8 times. 8 times 3 is 24 plus 4, that's, all right, so 7 times. All right, so 252. Okay, but we only need to round to 2 decimal places, so we already have enough information to round this. 1, 2, and there's a 7 after the 2, so we can round this to 300ths. All right, so that would be how you would do number 2. Number 3, Jim figures that the probability of drawing an ace from a normal deck of cards is 1/13, or 800ths. Which number is more precise and why? All right, well, let's divide 1 by 13 and see what we get. All right, 13 will go into 100. How many times? Well, it's probably going to be about 8, so let's do 13 times 8 and see what we get. 8 times 3 is 24, and 8 times 1 is 8 plus 2 would be 10. Okay, so too big, so let's try 7. Okay, 91. Okay, so 13 will go into 90. Let's try, well, if it went into 91 7 times, it's going to be 6. Okay, so 6 times. Okay, we can already see that our fraction is going to be more precise because if you divide your fraction, you're getting 0.076. So this answer is obviously rounded. Okay, so we're going to choose our fraction for a more precise answer because, and why? Because this one has clearly been rounded. So it's not exact. All right, so that's just some more exercises on probability. Chance. All right, chance is the second part. Besides expressing probability as a fraction or as a decimal, we may also express probability as a percent. We often use the word chance when expressing a probability in percent form. So chance is the same thing that you're comparing, number of favorable outcomes to number of possible outcomes, but it's always expressed as a percent. All right, so if you were thinking about it as a fraction, it would be out of 100, okay, because it's always expressed as a percent. So let's look at number 4. The weather forecast stated that the chance of rain was 40%. What is the chance that it will not rain? Okay, this is easy. If the chance of rain is 40%, then the chance that it won't rain is 60%. What about number 5? What is the chance that a flipped coin will land heads up? Well, we know the probability is 1/2, and chance is the same thing, we just express it as a percent. So 1/2 is equivalent to what percent? 50%. Okay, so it's the same thing, but make sure if they're saying chance that you are putting a percent. Number 6, the probability of selecting a heart drawing one card from a deck is 0.25, 2500ths. What is the chance that a card drawn from a deck will not be a heart? Okay, well, if the probability of drawing a heart is 2500ths, then the probability of not drawing a heart would be 7500ths. And as a percent, that would be 75%. All right, so this is very similar to probability. Just make sure you're stating it as a percent. All right, the third part is odds. Now, odds are different, okay? Odds are not stated as a fraction, and it's not what you want to happen to everything that could happen. It's the favorable to the unfavorable. It can also be written with a colon. When you write odds, you write them with the word to or with a colon separating the two numbers. Okay, so odds are what you want to happen compared to what you don't want to happen. All right, so it is a little bit different. Okay, so if they're using the word odds, you need to make sure you understand what they're talking about. It's not what you want to happen to everything that could happen, what you want to happen to what you don't want to happen. Okay, so example 2 says a 20% chance of rain was forecast. Okay, a 20% chance of rain. What is the probability that it will rain? All right, well, a 20% chance, that's 20 out of what? 20 out of 100. All right, so we already have a probability. We have a fraction. We just need to reduce it. So that'll reduce to 1/5. What are the odds that it will rain? All right, so odds are stated as what we do want to what we don't want. All right, so we know that 1 out of 5 is the probability that it will rain. So our top number is going to be 1. Now, if it's 1 out of 5, then what out of 5 is the probability that it won't rain? 4. So our odds are 1 to 4. 1 out of 5 to 4 out of 5. Okay? But if you write it like this is actually not correct. You should write it 1 to 4 or 1 to 4, like that. All right? Example 3. The odds that a marble drawn from a bag will be red are 3 to 2. What is the probability that a red marble will be drawn? Okay, so if the odds of drawing a red are 3 to 2, how many red marbles are there? There are 3. Now, how many marbles are in the bag? There are 5, because you have 3 that are red and you have 2 that aren't red, because they were using odds here, favorable to unfavorable. So the probability of drawing a red would be 3 out of 5. What is the chance of drawing a red marble? Okay, well, 3 out of 5, that's equal to what percent, or what over 100? Well, 5 times 20 is 100, so 3 times 20 is 60. So the chance of drawing a red marble is 60%. Okay, so the chance, the probability, the odds of drawing a red marble are good. Okay, look at the next question. 1 marble will be drawn from a bag containing 3 red marbles, 4 white marbles, and 5 blue marbles. What is the chance of drawing a red marble? Okay, so chance, favorable to possible. So we want a red marble, and there are 3 red marbles, so we have 3. And then out of how many possible marbles? 3, 4, 5. 5 plus 4 is 9, plus 3 is 12. So 3 out of 12, or 1/4. And that's our answer? No, because it said chance. 1/4. So what percent? 25%. Okay. Number 8, what is the probability of drawing a white marble? Okay, well, there are 4 white marbles, and again, out of 12, so that's going to be 1/3, and we can keep that one how it is, because probability is stated as a fraction. What are the odds of drawing a blue marble? All right, well, there are 5 blue marbles, but remember, odds is what we want to what we don't want. So we don't want to draw red, and we don't want to draw white. And there are 3 red and 4 white, so there are 7 options that we don't want. So the odds are 5 to 7, okay? So again, make sure you understand the difference between odds and chance and percent, or chance and probability. All right, the fourth and last part of the lesson is statistical probability. Okay, statistical probability is based on statistics. Okay, so it's similar to probability, but it's based on what you might call hard facts or real data. Okay, if you look at the middle of 628, it says we can distinguish between theoretical probability, something that's just a theory that you're thinking might happen, and statistical probability. Theoretical probability can be calculated when the number of favorable outcomes and the number of possible outcomes can be counted without testing. Games of chance are based upon theoretical probability involving actions with cards, dice, spinners, and similar objects with countable outcomes. Statistical probability is used to determine the likelihood of an event based upon a record of past experience. For example, a baseball manager may select a pinch hitter by comparing the batting average of several players against the right-handed pitchers. Suppose a baseball player has had 125 hits and 375 at-bats against right-handed pitchers. The manager can calculate the probability that the player will get a hit by dividing the player's previous number of hits by the previous number of at-bats. Using a statistical probability, we assume that the number of times an event happens out of the number of times the event could have happened is the probability of the event. Statistical probability is used by the insurance industry, which assesses risk and calculates insurance premiums on the basis of statistical records. And insurance premiums are the prices that you pay to have insurance. All right, so all of that is based on statistics. If you're buying health insurance, then the way that whoever you are buying that from is calculating how much you're going to pay, they're factoring in the statistics of everybody who is going to have health problems, what kind of health problems you might have, and your premium, the amount you pay for that insurance, will be affected by all of those things. So this is real world stuff that's being calculated every day, and it's affecting your life in a lot of ways. Okay, so we're going to work a couple of problems that deal with this. Number 10. During the last 3 basketball seasons, Darcy has made 64 free throws and has missed 32 free throws. What is the statistical probability that Darcy will make her next free throw? All right, well, how many free throws has she made? She's made 64, and that's what we want to happen. But out of how many shots? All right, well, she's shot 64 and she's missed 32. So if you add those together, that's the number of shots she's taken. Okay, so 64 plus 32 is 96. So out of 96 shots, she has a record of getting 64. So that's her statistical probability. And we can reduce this, of course. 64 divided by 8 is 8. 96 divided by 8 is 12, and we can reduce that to 4 going into 8 twice and 4 going into 12 3 times. Okay, so she has a 2/3 probability of making a free throw just based on her past activity. All right, so number 11, during clinical trials of the new medication, 15 out of the 1,000 participants developed unfavorable side effects. If Roger is treated with the new medication, what is the statistical probability that he will develop unfavorable side effects? All right, well, so far, 15 out of 1,000 have developed unfavorable side effects. So we can reduce that. 15 divided by 5 will be 3. 1,000 divided by 5 will be 200. So 3 out of 200. Okay, so and you'll hear about this when you're watching TV and you see those medication commercials. You'll hear in the background, 1 out of 100 patients experienced, rash, fatigue, and blah, 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 all of that good stuff. So it is calculated and it is recorded. All right, and then number 12. If unmarried drivers under the age of 25 are far more likely to be involved in an auto accident than drivers over the age of 25, then what is probably true about the insurance rates for younger drivers versus older drivers? All right, well, unmarried drivers under the age of 25 are far more likely to be involved in an auto accident. If you're under 25, you're probably going to be paying higher premiums because it's just more likely statistically that you're going to get in an accident and that the insurance company is going to have to help you pay for the damage. So they're going to make you pay more for your premiums. All right, so you might go, well, that doesn't sound fair. What if I'm a really good driver? Well, unfortunately, it has been proven that the younger you are, the more likely you are to be in an accident, just because you're not as experienced and sometimes younger people are a little bit more careless. So those are things that are going to affect you when you start driving. Let's say you start driving when you're 16. All right, your insurance is probably going to be more expensive than somebody much older than you just because you're not as experienced. And that just makes sense. So this is all kinds of things that different companies are keeping track of. And if you work for a company that does these kind of things, then it might be something that you have to keep track of and some data that you might have to consider. So anyway, that's the difference between probability, chance, and odds, and a little bit on statistical probability.